In this video, we're going to learn how to build a 555 timer circuit to blink an LED. To build this project, we'll need a 555 timer, an LED, a 100 microfarad electrolytic capacitor, two 5.1 kilo ohm resistors, and a 220 ohm resistor. So, let's build it. The first thing we want to do is bridge both buses. This way, power and ground will be available on both sides of the breadboard. Then we'll add the 555 timer IC. Now we'll connect the reset pin to the voltage input pin. This enables the 555 timer. You can ground this pin to reset the timer. Next, we're going to connect the trigger pin to the threshold pin. Then we connect the power supply pin to the supply rail of the breadboard, and the ground pin to the ground rail of the breadboard. Now we need to connect a capacitor to the trigger pin of the 555 timer. We're going to use a 100 microfarad electrolytic capacitor. And then we need to ground the capacitor. Next, we're going to connect a 5.1 kilo ohm resistor to the discharge pin, and then connect the other lead of the resistor to the supply rail of the breadboard. Then we need to connect the threshold and discharge pins with another 5.1 kilo ohm resistor. Lastly, we need to add something for the 555 timer to control. We'll add a blue LED and connect the 555's output pin to the LED's anode. We'll connect the LED's cathode to ground with a 220 ohm current limiting resistor. Let's connect a 9-volt battery to the bus and our LED will start to flash. Okay, so let's talk about this circuit. First, it's important to understand that the 555 timer has different modes. Some of these modes require an external trigger be sent to the timer. Since our circuit is in astable mode, we won't have an external trigger, and therefore we need to tie it to the threshold pin. More about this in the next 555 timer video. Next, we added a capacitor to the trigger pin. This capacitor will be continuously charged and discharged. Lastly, we added two resistors. These create a voltage divider. Together, the values of these resistors and capacitors will determine the speed at which our timer operates. For example, if we switch out the 100 microfarad capacitor for a smaller 42 microfarad capacitor, the LED will begin to flash much faster. And if we replace the capacitor with a much larger 220 microfarad capacitor, the LED will begin to flash much slower. I recommend you take some time and experiment with different values of resistors and capacitors to see how they change the timing. Well, thanks for watching this video, and I hope you take a minute to subscribe. And for even more tutorials and schematics, check out TheGeekPub.com.